When I was in middle school, I learned that 3 plus 5 is equal to 5 plus 3. It's pretty straightforward. Like there's 8 pens, and I could either give you 3 and then 5, or 5 then 3. The order does not matter, right? If you think about it, this idea is really helpful because it's particularly featured in exercises when you train in middle school and even in high school. You have it for addition, for multiplication, like 2 times 5 is the same as 5 times 2. And recently it was featured on one of the Black Pens, Red Pens shorts. Let me show you. So you go on his channel and you saw about the most viewed, and it's this one about percentage trick and reality. Here he can swap the percentage to calculate this percentage easier, and that gives 3. I'll let you watch the end of the video after this one, but maybe you'll be able to guess the end, right? So it uses the same idea again for multiplication. It's called commutativity, and it's the fact that order does not matter. So in high school, I thought that commutativity was something that was the norm rather than the ordinary, and I encountered the first example of non-commutative objects. Let me show you. So one place where order matters is transformations. So if I take this book and I rotate it and then I flip it about this axis, it ends up in this position. But if I do the reverse with this one first, I flip it this way and then I rotate it, you see that they're not in the same positions. This one is facing this way and this one is facing that way. So order did matter here. But then some time passes and I still have this idea that commutativity is the norm and order is something that is really kind of niche. Like you shouldn't just need it in some case, some special case of mathematics. And I did not realize how common it was yet, until I stumbled onto this brilliant video from MIT OpenCourseWare. It was a lecture from Gilbert Strang who said this. Let me show you.
Example in the book, it's just why do you do that inverse things in reverse order? It's just like you take off your shoes, you take off your socks. Then the good way to invert that process is socks back on first, then shoes. Sorry. Okay, I'm sorry that's on tape, but all right.
That single moment in the video made me realize how much order really matters in real life and how much you can think of non-commutative things and then transcribe them into mathematical objects, for instance. I mean, except for cereal and milk, people do not seem to agree in which order you have to put them in, but anyway, like if I want to walk, I have to stand first. I have to stand, then I can start walking. I cannot do the reverse. But then you find million examples of non-commutative things like the order of words in a sentence matter, the order in which you follow a recipe matters. It just makes sense. When you look at a timeline and you pick up events, it gives a lot of example of things in which order matter, like first Grant started this contest and then I applied. I could not apply before he did start the contest. So time gives a lot of example of non-commutative things. But hold on, there is more. 2 years ago at university, I stumbled onto this video of Alan Cohen's. He talks about the fact that non-commutativity implies evolution, and with evolution he means time. Like, this was part of his results in von Neumann algebras, and he realized that his results meant that non-commutativity means time. He even tells a story about Heisenberg, and this story is about his escape at Helgoland, where he said he might have stumbled onto the fact that physics at its quantum level is not really commutative. Like, you could not handle or write expressions like E equals mc squared, and he said that the order matters in that case. Like, mc squared would not be the same as c squared m. That fact just completely blew my mind. I didn't thought that we could understand physics in such mathematical paradigms, and he even talks about time being an emergent variable. Like, we should not write all of physics in terms of time. Maybe there's something like hidden into space itself or the structure of the universe that is the real cause of time, and then we should understand like things like quantum mechanics, quantum intrication and quantum effects in terms of what I could say the real variable. And this would mean that actually everything is non-commutative, and the fact that this property of commutativity emerges in some rare cases means that it's not the norm, it's rather the exception. And now I can fully digest the fact that 3 plus 5 equals 5 plus 3 is really a rare exception. Now, if you know some physics, maybe you can relate this to entropy or information. As a great follow-up to this, there's a video from Veritasium which is called What is Not Random, and you should go and watch it. He talks about information and entropy, and maybe you can sort of link it to some of the things that I said. Also, if you know a bit of French, maybe you can go ahead and watch the interview from Alan Cones. Anyway, I hope you learned something. This was my first entry as SOME, so the Summer of Mathematical Exposition, started by Grant Sanderson. Thank you for watching.